There is a tree whose leaves contain all 9 essential amino acids, the full set the human body cannot produce on its own. This is extraordinarily rare in the plant kingdom. Soybeans do it. Quinoa does it. And this tree, which grows wild in some of the hottest, driest, most nutritionally desperate regions on Earth, does it quietly, in abundance, with almost no care required. By the middle of the 20th century, Western agriculture had nearly forgotten it existed. Not because it failed, because no one could figure out how to sell it. The human body synthesizes most of what it needs. Given raw materials, carbon, nitrogen, the architecture of digestion, it can build thousands of compounds from scratch. But there are 9 amino acids it cannot produce. These must come from food. They are called essential not because they matter more, but because without an external source, the body simply does without. Most plant foods offer incomplete profiles. Grains lack lysine. Legumes lack methionine. This is why traditional diets around the world combine them, rice with beans, bread with lentils, to approximate what meat provides automatically. But there is a tree. Its leaves, dried and measured, contain all 9. Isoleucine, leucine, lysine. The full sequence, in proportions the body can use. This alone would make it unusual. But there is more. The same leaves, weight for weight, contain more iron than spinach, more calcium than milk, more potassium than bananas, more vitamin A than carrots. These are not marketing extrapolations. They are the results of compositional analyses conducted in the second half of the 20th century, when food scientists finally turned their attention to a plant that rural communities had been eating for 4,000 years. And yet, most people in the industrialized world have never heard of it. The first written references appear in ancient Sanskrit texts, Ayurvedic treatises that classified plants by their effect on the body. The leaves were described as heating, stimulating, capable of addressing weakness. The roots, the bark, the flowers, the seeds, all were catalogued. This was not folk belief. It was systematic botanical observation, conducted centuries before European science had a name. In the northern reaches of the Indian subcontinent, where the tree grew wild in the foothills, it was simply part of the landscape. People ate the leaves as vegetables. They pressed oil from the seeds for cooking, for skin, for lamp fuel. The young seed pods, long and slender, were prepared like green beans. Nothing was wasted. By the time of the Mauryan Empire, 3 centuries before the Common Era, there are indications that preparations made from this tree were given to soldiers. Whether this was medicinal or nutritional is unclear. Likely the distinction did not exist. The tree traveled along trade routes. It reached the coasts of East Africa, carried in the holds of merchant ships, or perhaps simply planted by travelers who knew what it could do. In the dry Sahel, in the sandy soils of Senegal and Mali, it rooted and thrived. Local names emerged. In some regions, it became known as the never-die tree. In others, mother's best friend, a reference to its use by nursing women. The Egyptians knew it, not the leaves, but the oil. They pressed the seeds and used the extract in perfumes, in embalming rituals, in cosmetics that have been found in tombs. The Greeks knew it too. Dioscorides, the Roman-era physician who cataloged hundreds of medicinal plants, described the oil's clarity and stability, how it resisted rancidity in the Mediterranean heat. But Europe did not adopt the tree. This is important. The plant was observed, its properties noted, its oil traded. Yet it never entered European agriculture. The climate would not permit it. The tree cannot survive frost. But more than that, Europe was developing a different agricultural logic. Grains, pasture, commodities that could be stored, shipped, measured by the bushel. A tree whose value lay in its fresh leaves did not fit. And so, for centuries, it remained the food of other places, of South Asia, of sub-Saharan Africa, of the Philippines, where Spanish colonizers found it already cultivated, of Haiti and Central America, where it arrived later through paths no one fully documented. It fed people. It continued to feed people. But it did so invisibly, outside the systems that would eventually define what counted as food. When industrial agriculture emerged in the 19th and 20th centuries, It brought with it a set of requirements that had never existed before. Food, to be valuable, had to be storable. It had to survive transport, weeks in cargo holds, months in warehouses. It had to be uniform, measurable, compatible with machines. Wheat fit this model. Rice fit it. Corn eventually came to define it. This tree did not fit. Its leaves, once picked, wilted within hours. There was no infrastructure to dry them at scale, no demand from processors, no market waiting. The seed pods, tender when young, became fibrous if left too long on the branch. Timing mattered in ways that industrial logistics could not accommodate. Worse, from an economic perspective, the tree grew too easily. It required no fertilizer. It tolerated drought. It could be planted from a cutting and begin producing leaves within months. For subsistence farmers, this was a blessing. For commercial agriculture, it was useless. There was nothing to sell them, no seed stock to patent, no annual inputs to require. Colonial administrations, where they noticed the tree at all, dismissed it as peasant food. They promoted cash crops, cotton, coffee, sugar, that could be exported and taxed. Indigenous food systems were not merely ignored, they were actively dismantled. Land that had once grown diverse crops for local consumption was converted to monoculture. Knowledge passed down through generations began to erode. By the mid-20th century, in many parts of the world, the tree had become a relic. It still grew in backyards, along roadsides, in the marginal spaces where nothing else would thrive. But it had disappeared from official agriculture, from cookbooks, from nutrition guidelines, from memory. The plant did not fail. The system had no place for it. It was not until the 1970s and 1980s that researchers began to revisit this tree with modern analytical tools. The findings were consistent. Dried leaf material contained between 25 and 30% protein by weight, comparable to eggs, higher than most legumes. The amino acid profile was complete. The iron content was substantial and, unlike the iron in spinach, appeared to be relatively bioavailable due to the presence of vitamin C in the same tissue. The leaves contained beta-carotene, the precursor to vitamin A, in concentrations that rivaled orange-fleshed sweet potato. They contained calcium in amounts that, gram for gram, exceeded dairy. They contained antioxidant compounds, flavonoids, phenolic acids, at levels that attracted attention from food chemists studying oxidative stress. None of this was new. The tree had always contained these things. What was new was the documentation, the quantification, the placement of this knowledge into a framework that Western science could recognize. And then there was the question of where it grew. The tree thrived in exactly the conditions where malnutrition was most severe. It tolerated soils too poor for conventional crops. It required little water once established. It grew in the heat of the tropics, in the dry seasons when other food sources failed. It could be coppiced, cut back repeatedly, and would regrow, producing new leaves month after month. For famine relief organizations, this was significant. In the 1990s and 2000s, programs began distributing seeds and cuttings in regions facing chronic food insecurity. In Senegal, in Niger, in parts of India where government nutrition programs had failed to reach the poorest communities. The logic was simple. Here was a source of vitamins and protein that required almost no investment, that could be grown in a backyard, that could be harvested by hand and eaten fresh or dried for storage. The results were documented in field reports, in public health assessments, in the quiet work of agricultural extension officers who understood that sometimes the best intervention is the one that was already there. The tree is called moringa. In English, it is sometimes known as the drumstick tree, a reference to the long, slender seed pods that resemble the instruments. In Hindi, it is sahjan. In Tagalog, malunggay. In parts of Africa, it carries names that translate roughly to the tree of life. It grows today in nearly every tropical and subtropical region on Earth. In India, where it originated, the leaves are cooked with lentils or stirred into rice. In the Philippines, they flavor soups and stews. In East Africa, they are dried and ground into a powder that can be added to porridge, to sauces, to anything that needs fortification. The The tree itself is unassuming. It reaches heights of 10 or 12 meters if left unpruned, but most growers cut it back regularly to encourage leaf production. The leaves are small and compound, arranged in feathery clusters along delicate stems. The flowers are pale, cream-colored, lightly fragrant. The seeds, encased in their long pods, can be pressed for oil or roasted and eaten. It grows in poor soil. It survives drought. It asks for little and offers much. For those who want to grow it, the conditions are straightforward. It needs warmth. Frost will kill it. It needs drainage. It will not tolerate waterlogged roots. Beyond that, it is forgiving. A cutting planted in spring can produce harvestable leaves by summer. A tree established for several years can yield continuously, pruned and regrowing, season after season. It never disappeared entirely. It was always there, in the places where people still knew what it was, in the backyards of grandmothers who remembered, in the agricultural margins that industrial farming never reached. What changed was attention. The knowledge was always here. We just stopped looking.